In this video, we're going to talk about two keywords, very important keywords in C, and this also applies to Java and C++. So these two keywords, they are called break and continues. There's actually another one called goto, but we're not going to discuss that one. So these loops are, as we discussed, for loop, right? While loop. They could also be the do while loop, right? Okay. And remember, we're talking about loops here, okay? We're not talking about conditionals, like the if, right, else. We're not talking about those. Those are conditional statements, right? They're not loops. We're talking about loop statements involving for loop, while loops, and do whiles, etc. Let's talk about break. So this break keyword, you might have seen this is in switch case, right? When we discussed that earlier, you see this break keywords. So break is used to break out of a loop. Okay, so what you see here is a while loop and a for loop. So what we have is essentially a nested loops, both outer, right? So the while loop is the outer loop, and for loop is the inner loop. Okay. Now, if you look at this carefully, this yellow portion here is part of your for loop, and this for loop is the inner loop. So when you have break, and this break is forget about this if, right? Maybe there's not if. It doesn't matter where this is. This break is, as long as it's sitting inside the inner loop. Now this break breaks, right, out of the inner loop only, okay? So if you have nested for loop, while loops, and do while loops, doesn't matter how many levels that you have, wherever you have a break, and that break is inside one of those for loops in a nested fashion, that break only breaks the closest loop, right? In this case, for loop right here. So this breaks out of the for loop ends right here into the while processing. So your flow of control will simply exit abruptly at this line. Let's say this is line 99, then you'll end right here. Maybe there's line number 100, all the way to 200, right? Through to the end of your for loop. None of this is gonna get looked at, okay? Your line 99 says break, it'll just break out of that current for loop, taking you into the very next line of your while loop, okay? Let's examine the two styles. One of them is the bad style on the left side, okay? And this is the better one, not necessarily the best, but let's kind of just examine this, right, against this. All right, so what you see here on the left side, this is actually an infinite loop, okay? In fact, syntactically correct, you can actually compile this. The problem is it will just keep running over and over again because, first of all, you don't have initialization, you don't have the conditional expressions, you don't have increment decrement. This simply just runs on forever and ever, right? And of course, every time an iteration goes through line 5 and 6, your condition is going to be checked only if the condition is true, right? If this is true, then it breaks, then you're good, right? But unfortunately, the limiting condition, which is this line, right, 5, what if the condition is never true, right? Then your computer is going to keep running and running until it goes up in smoke. So that's not good. A better way of writing this is to put this limiting condition as part, as you know, the condition is an expression, right? Evaluates to either true or false. This is an expression. It's a singular unary expression that gives you either one or zero. So that's good. You might as well just lift this up, right, into this conditional part of your for loop, and that will check for you, right? Instead, still, it's not as safe because you have to make sure that in your logic here, right, somehow inside this for loop, your condition is being reversed into a true, right? This is not condition, so you have to make sure the opposite is true. So while the opposite is false, that way you can stop this, right? For loop once and for all. So that's one area, right? And of course, you can also have this. This is the second scenario, which is also bad, right? Why is it bad? Well, because now you have two variables here. You're checking to see if this x is 1 or 0, right? 1 or 0. So if this is 1, right, what's going to happen is your while, so 1 is what? 1 is true. then this thing will just keep going and going. In fact, X can be 10 or 20 or 30. When you are evaluating the condition, and remember, when you have a number, right, an implicit type conversion converts that integer, right, a non-zero integer into what? Non-zero in, right, is converted into true, okay? Now, 0 in is implicitly converted to a false. Okay, so if you're 0, you're good. Your entire loop is not infinite. However, if X is a non-zero end, it's always going to be true, and this is going to be forever. You're going to run this, into your computer into the ground. So unless, right, your condition is met, right, just similar to this one right here, right, then you can break out of it. Otherwise, you're doomed, right? The entire program just keep on running and running. So a better way of running this is, now that you have two limiting conditions, X and conditions, right? The best way to go about it is put them into this conditional expression part of your loop, so that you can kind of check for it. So when both of these, right, conditions are met, your entire loop exits that way. The better solution is not to use break, right? Because there's only maybe like 10% of chance you're getting into this break. It could be that your logic is flawed and this break is never reached. So a better way to go about this is to institute all of your limiting conditions inside your, so this is kind of an engineering best practices. Let's review this other use case as we speak. This is another example of not using a break keyword. So if you're not using a break keyword, you can alternatively, make use of what we call break flag. I mean, this is just a variable. Technically, you can name it X, Y, and Z. Obviously, you don't want to do that. X, Y, Z connote to no context. So you want to make sure that your naming of your variable makes sense, right? Syntactically sense. So in this case, we're using break flag. Break flag is an integer, or it could be a Boolean. In this case, you're setting it to true, false. Whatever this complex logic is, it'll set your flag, right, from true to false, false to true. Eventually, if you set it from true to false, then not false is going to be true. It'll still keep going, right? But let's say if your break flag is 1, right, not break flag, right, not, right, this is not. It's going to negate the value of 1 to 0. In this case, while false, your entire loop exits basically at this point. So this is another example of not using a break keyword, but simply using a flag that you can toggle on and off to accommodate for this complex limit test. So this is another way of like exiting your infinite while loop. So the continue keyword is also available in various looping structures, right? Like while loop, do while, and for loop. So wherever you see a continue, let's say in the middle of your loop, continue simply, right, takes your entire flow of control back to the conditional associated with that looping structure. So for the while loop, this continue takes you right back to this one. Let's say if you have another 100 lines right here, it doesn't matter. They will not be evaluated. As soon as your flow control lands on a continuous statement, that takes you back to the conditional. So you can continue your iteration, from beginning of that iteration all the way to the continue again, and then you go back to the expression, so on and so forth. Same thing with the do while, right? Except for do while, this is our post test, right? Our post test happens at the end of your statement. All of this statement executes, right, until you see the continue. And it doesn't matter how many of these lines of code you have after continue, they are not even going to be looked at. You'll continue to take you back to the post-test condition, and that will kick off another iteration, so on and so forth, as long as your expression is true. For the for loop, it's the same thing. As you know, for loop has 3 compartments, right? The first is init. The second one is the conditional, right? The third one is the increment and decrement, okay? So don't care about the third one. Don't care about the first one. As long as you see it continue in the middle of your for loop, that takes your entire flow of control back to the conditional to check for expression number 2, seeing if it is the true or false, right? If true, your for loop continues, goes so on and so forth until it reaches continue again. Now, it doesn't matter how many lines you have, codes, after you continue, they're not even going to be looked at. So that's the nature of continue. Remember, continue does not stop your program, right? And so is break. Break is not going to stop your program. They simply take the flow of control, right, into their respective spot. Continue, simply back to the iteration, especially the expression part of your iteration, checking to see if iteration should continue or not. Break, exit the closest inner, right, loop of all of your looping structures you have in a nested fashion. Or if this is the only looping structures you have, then that break, exit out of that current loop. This is an example of continue. So you have 2 versions of pretty much the same program here, right? So this one and this one is called read average. So this read average function, this is actually a function, not a program, reads in something, right? Presumably at runtime, user enters something from keyboard, and that gets read, right? As long as, this is not in a file, right? That's not in a file. So as long as don't key in a file, and this thing just keeps on reading what you enter from your keyboard, as long as this n, right? This n is an integer, okay, is not a 0, right? If this is 0, then it continues. So what happens is, if continue is met, then this is going to take what? You back into this expression. This entire expression is checking for, right, your stream coming from your keyboard, whatever this string is, as long as this is not in a file. So your line 15 and 16 will never be met, right? But if n is not 0, right, assuming n is, it could be -1, right, 2,300 or whatever, then 15 and 16 will be evaluated. So 15 computes the sum, right, of all of the integers that you entered. Simply count the number of integers that are not 0, basically, right? So meanwhile, if you look at this example here, everything else is the same, right? Just look at this entire example. It's the same thing. We have, continuous input of integers into this buffer, as long as this is not in a file. If n is not 0, then you compute this, right? The cumulative sum, and also the number of integer that is not 0. So basically the same logic as this, right? The only difference is one involves the use of continue, right? If n equals 0, there's no point in continue on. I just want to go back to my reading. This takes the user, right, or the flow of control back into that expression to continue reading. Whereas this one doesn't do that. Instead, it will compute, right, if n is not 0, right? But if n is 0, right, again, it's going to be at the end of if. It'll simply take you back in there. So one involves use of continuity, the other one doesn't. There's really not a efficiency differences as much, since this is very simple business logic that doesn't take long to execute. But this illustrates use of continue versus not using it.